Hello everyone, welcome back to Arduino and My Robot. This is chapter 10, and in this we'll be learning about serial communication. So what basically is serial communication? Serial is used for communication between Arduino board and a computer or other devices. All Arduino board have at least one serial board, and these are also known as UART or USART. Serial, it communicates on digital pins 0, that is called as Rx, and 1, that is called as TX. And also we can communicate using our USB through our computer board. So basically, once when you connect your Arduino board with your computer, or if you want to get any message to be printed or to be given as a message to the person who is running the program. Suppose I want to print this message, I love this course using my Arduino board. I'll be using this serial communication. To use that, I will use the command serial with S capital. So you have to write serial dot begin 9600 semicolon. So as of now, you can just remember 9600. Note, and I'll not suggest you to know exactly why this is being written, but yes, there is an explanation to that. But for the basic, you can ignore it. You can just write 9600. Now, since I'm writing this serial dot write means that writing means this is an output. Okay, reading means you are taking something as input. So in this session, we are trying to print or give an output as a message. So this will give an message, I love this course. And see here, now I have written the code, void setup, serial.begin 9600, serial.write, I love this course. And I have not written anything in the loop section because I do not need anything to be repeated. Once you have done that, click on the serial monitor as shown in the bottom section, and you will get the result something like this. So what just happened, right? We have written some codes that was read by our microcontroller or Arduino here, and it was given as an output. So it is used, serial port is used when we want our Arduino to talk to us or we want to communicate with each other. In that case, we use this. Suppose, let's take an example. Suppose I have some LED light and or a buzzer. Buzzer is a sound alarm, and I want it to turn on as soon as I enter 1. If I press 1, the buzzer or the alarm should start, and if I press 0, the alarm should stop. So when you are putting 1, it is you are communicating with the board or the Arduino. You are giving an information from your side, from outside. You are not coding it inside. You are giving from outside. So it's a communication. So what we are doing is we are trying to communicate with our board by coding, and it is replying us in a way which we want. So this is our computer. This is our USB board, and this is our Arduino board. Okay, and we'll be using this board and this computer to communicate with each other, and this communication is done by serial port. Okay, in Arduino there are different type of serial communication that happens, and different pins are allotted for that. So first is SPI, that is serial peripheral interface. It is the fastest and used to communicate with devices. So suppose I have connected any device or any component at pin number 13, 12, 11, 10. Then that port is called as SPI, means serial peripheral interface. So this is the fastest one. Okay, when you want to use keep the delay time very less and response time very fast, so you will be connecting your component at these positions. Then we have I2C, that is inter-integrated circuit. For that, we'll be using pin number A4 and A5. Don't worry, we'll show you everything in image in the next slides. Okay, so these two pins are used for connecting two or more Arduino boards or secondary slave devices like Bluetooth or Wi-Fi, etc. Sometime we want to make a Wi-Fi controlled devices or Bluetooth controlled alarm system. There are projects that I'll share you the codes, or I'll be sharing you the links from where you can learn how to make those things like anti-theft burglar alarms. For that, or Wi-Fi remote controlled door opener. In that, what this Arduino board is not having any Wi-Fi connection. For that, we have different board. Then that board is to be connected with our Arduino board. For doing that, these Wi-Fi boards or Bluetooth boards, these are secondary boards. So we'll be calling them as a slave devices. Slave, why? Because they are not capable of working on their own. They need Arduino board to work. Okay. So that's why they are called as slave devices. So these slave devices are connected at pin number 4, A4 or A5. Then we have UART, Universal Asynchronous Receiver Transmitter. So that is connected at pin number 1 and pin number 0, TX and RX. TX is used for transmitting and RX is used for receiving, generally used for connecting computers with USB. And these are having communication on both sides, like from the computer to the board and board to computer. So here you see these boards are I2C, that is A4 and A5. These are I2C. Then here 13, 12, 10, 10. These are SPI. These are very fast. You can connect for fast responses. Then you have UART, double-sided communication. You can connect at 0 or 1. It is here. You can, if you will see on your board, it's written TX and RX. And then we also have two I2C. Here also A4 and A5 you can see. You can connect your slave devices here or here, Wi-Fi or other devices. So the coding part was serial.begin 9600. So as soon as we write this, computer understand that there is going to be some communication with Arduino microcontroller bit and the user. Okay. So this is the command that helps the computer or the Arduino board understand that it will be getting some input and it has to perform some output on the basis of those input. Okay. And we'll understand more detail about how to use this in the next upcoming project. And for that, thank you so much.